The majority of this video will be spent showing you how to simplify expressions such as these using the angle sum and difference formulas. However, first let's simplify a regular old trig expression. The first identity we ever learned was the Pythagorean identity, which said that sine squared x plus cosine squared x is equal to 1. And we quickly learned that if we subtract sine squared from both sides, that would give us cosine squared x is equal to 1 minus sine squared x. So I'm going to make this substitution right now, replacing cosine squared with 1 minus sine squared. So that's why we will have sine squared x times 1 minus sine squared x plus sine to the 4th power of x. So a little distributive property, and you will see that we have sine squared x minus sine to the 4th power of x plus sine to the 4th power of x. Then we notice that these are opposites. They will cancel out. So that's just going to leave sine squared x. Now let's turn our attention to the angle sum and difference formulas. So the sine of something plus something is just sine cosine plus cosine sine. So this is going to be sine x cosine pi plus cosine x sine pi. Okay, now cosine of pi, so here's your unit circle. So here's pi right here. Cosine is an x value, so the x value here is -1. So this is really sine x times -1 plus cosine x times, now sine is a y value, and right here the y value is 0. Now 0 times anything is just 0, so this is basically gone. So that's just going to leave negative sine x. When you look at a problem like number 14, I'm hoping you recognize that this is the pattern of one of our formulas. See how it goes cosine, cosine plus sine, sine? Now look at these formulas. Do you see that pattern? See how this has cosine, cosine plus sine, sine? So we know this is the same as the cosine of an angle minus an angle. So the two angles involved are here and here. So we need to rethink this as the cosine of 5 pi over 8 minus 3 pi over 8. So that's going to be the same thing as the cosine of 2 pi over 8, which reduces down to the cosine of pi over 4. And we know that the value of cosine of pi over 4 is radical 2 over 2. That's one of the facts that we memorized a long time ago. Looking at number 15, see how the pattern goes sine cosine minus cosine sine? Do you see that pattern here? Alright, hopefully you can see it's this one right here. That means it's the sine of something minus something. So this is going to be the same thing as the sine of 5 pi over 8 minus 7 pi over 8. So that's going to be the sine of negative 2 pi over 8, which is the sine of negative pi over 4. Okay, now the reference angle is clearly pi over 4. So we know that the sine of pi over 4 is radical 2 over 2. The only question is, will the sine of negative pi over 4 be radical 2 over 2, or will it be negative radical 2 over 2? And that depends on the quadrant. So don't forget that when we're talking about negative pi over 4, we're talking about moving in this direction, okay, clockwise. So that puts us in the fourth quadrant, and since sine is a y value, it is negative here, so the answer should be negative radical 2 over 2. Alright guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.